Hi friends, under electrostatics we are discussing about capacitance and we have seen Gauss law, Gauss theorem, its proof and its applications and how to deduce Coulomb's law from Gauss theorem and how to calculate the field due to infinitely long straight uniformly charged wire. And in the case of a spherical shell, what could be the field intensity outside and what could be the field intensity inside. And also we have seen the case of non-conducting charged solid sphere. What could be the field intensity inside, on the center and on the surface. And now an interesting phenomena we'll try to look in now. So when you talk about a capacitor, its basic purpose is to store large amounts of electric charge in a small space. This is the basic idea of a capacitor. You can store large amounts of electric charge in a very small area. How you are able to do that? So you are taking just two conductors and they are being separated by an insulating medium. Now, generally what happens is the two terminals of the battery can be connected to these two conductors to get them charged. Let us say I have taken a conductor. I have given positive charge to this. Its potential is, let us say, V1. Now I have taken another charge. Let us say I have given a negative charge to this. Its potential is V2. Now here, in between the distance of separation, I have insulating medium. Now naturally the positive charge is accumulated here and the negative charge is accumulated here. This is how you can see the geometric approach of a conductor. Now if you take conductor 1, its potential is plus Q. Its potential we are calling as V1. And if you take the other conductor 2, its charge is taken as minus Q and its potential is equal to V2. Now from these two, if you calculate the net charge, it is Q1 plus Q2, that is plus Q minus Q. Then automatically it will be 0. But interestingly, if you take the potential difference, which we ultimately call it as voltage, that PD, potential difference, is also known as PD. PD is V1 minus V2 or V1 difference V2. This is V. Remember that the potential is not 0. The net charge is 0. And if you look at this diagram, we all know that in the region between these two conductors, if you calculate the electric field intensity, it depends on the charge. That means in the region between conductors, if you take, electric field intensity is proportional to the charge. Now, just now we have identified that potential difference is equal to V. What is potential difference or voltage? It is nothing but work done per unit positive charge in taking small test charge from conductor 2 to conductor 1 against electric field. Exactly what does it mean? This is the region between the conductors. So the field is acting like this. Against this field, if you bring another test charge and move it to this side, that means from C2 to C1 when you are moving, the work done per unit positive charge in bringing from second conductor to the first conductor so that it is working against the field, that is what is being defined as the potential difference or voltage. So from this, what we can understand, if there is more charge, there will be more voltage. Therefore, we can also conclude from this that V is proportional to Q. So therefore, what we can infer from this is, when you say V is proportional to Q, therefore ratio of Q by V must be constant. That is, Q by V is equal to constant. This constant is what is defined as capacitance. This constant is what is defined as the capacitance. But interestingly, two important things you have to understand. This capacitance you are talking about, it does not depend on either Q or V, but it depends on geometrical configuration. What does it mean? The capacitance of a capacitor does not depend on either charge or voltage. It depends on the shape. Geometrical configuration means it can be shape, it can be size, it can be distance of separation of the conductors. And C, that is the capacitance, also does not depend on the nature of the material of the conductors. What type of materials you use to prepare the conductors also doesn't matter here. So if you take the equation Q by V equal to C, suppose if the potential is equal to 1 ohm, ohm is represented like this, then automatically Q is equal to C. So therefore you can define capacitance from this. Capacitance is the amount of charge, because it is equal to Q. Amount of charge required to raise its potential to unit. So to get a potential of 1 ohm or unit ohm, the amount of charge required is nothing but its capacitance. That's how we represent. So if you take the units of this, you know very well, it is measured in farad. Farad is the unit named after the great man. So, but this is a bigger unit. So we have other units also. Suppose I say microfarad. Farad is represented as F. Microfarad. So a microfarad I will represent 1 mu F. Mu is the symbol. That is nothing but 10 power minus 6 farad. You also have nanofarad, another smaller unit. So that is represented as 1 NF, nanofarad. That is 10 power minus 9 farad. Interestingly, sometimes we use the word microfarad. Very small unit. So how we write it? We write as 1 mu f. We write microfarad. 10 power minus 6, 10 power minus 6. That is 10 power minus 12 farad. This is what is termed as picofarad. So this is how we measure the capacitance. Okay, let us go further. Let me give a hint to understand the need for going for a smaller units of capacitance. For example, let us look at capacity of the earth. Earth capacity. I am taking as a spherical shell. We know that the radius of the earth is 6400 kilometers. Now I can represent as 6.4 into 10 power 6 meters. Now if I take the capacitance of earth, the formula is 4 pi epsilon naught r. This 4 pi epsilon naught is nothing but 1 by 9 into 10 power 9. So therefore, if I calculate the capacity, that is 1 by 9 into 10 power 9 into radius 6.4 into 10 power 6. Now this will come to around, having computed, I got it as somewhat 0.711 into 10 power minus 3 farad. Now, if I want to convert into picofarad, it comes to around 711 microfarad. Very interesting. The size of the earth appears to be very huge, but its capacity is found to be very small. And that is the reason why we need smaller and smaller units to measure smaller capacities. Now, why this is happening like this? If you take the earth, we can say it is a big sphere. Even then, only 711 microfarad is the capacitance. So capacitance is found to be low. So in general, if you say capacitance when you are measuring, generally you will get it in nanofarads or you get it in picofarads. So these two are generally used for capacitance of the earth. If the capacity of the earth is like this, you can imagine the capacity of the other condensers also. Capacitance is also sometimes known as condenser. Though there is a small difference. Right now understand that for present sake, both capacitor and condenser are one and the same. So farad is the biggest unit of capacitance. That is what we have to understand. Now if you see this expression, this is the value I have used. Capacitance equal to 4 pi epsilon r. How it has come? So let us take the case of an isolated spherical conductor and obtain its capacity. That is the next agenda.